Let's go ahead and take a look at your homework 2. Okay. I want to go ahead and complete it here on the video, and I'll take pictures as well. Okay. First part over here, again, we're taking it step by step when it comes to our homework for this unit to make sure, hopefully, we feel pretty comfortable. Is what reason why we're doing our homework step by step. First thing is, they're asking to label the O, the A, and the H, right? The 3 legs of a right angle triangle. First thing is, what I do is I find where my right angle is, and I draw a line on the other side, and that's always my hypotenuse. I find out and identify where my theta is, and my right angle, and that's my adjacent leg, and left over is my opposite, okay? That's how I do it. Again, if you do it a different way, well then do it your way. You don't have to do math my way, you can do it your way. But I do expect you to show me your answers. Last unit, there was quite a few of us who did not show answers, and you are not going to receive full credit, okay? So get me the steps instead of just showing me the number, okay? I don't want just the number. That does nothing for me, okay? Because there's going to be times where you're going to need help, and I'm not going to be able to help you if I do not know your steps, okay? Just Googling what the answer is or just tossing down a number is not going to help me. Okay, let's continue here. Here's my right angle. Go draw an arrow to the other side. That's my hypotenuse. Here's my theta and my right angle. That's my adjacent and my opposite. Hypotenuse, adjacent, opposite. Opposite side is my hypotenuse, my adjacent, my opposite. Okay, so that's labeling the right angle of a triangle. Now over here, when you go to do this, what do you need to do? You need to get that calculator that you're using. If you're using one similar to this or the one that the school provides, that's perfectly fine. When you turn it on, you're going to come over here and you're going to hit the mode button. We're going to scroll down to where it says degrees and it's flashing. I hit enter next. Now I can clear it out and I'm in degrees, okay? So just double check to make sure you're in degrees first. You're going to come over here and you're going to hit the sign. Here's the sign key of 25. I always like to close my parentheses, hit enter, and I get a number value of 0.423. When I'm working with thetas, I like to go out at least maybe 4 or 5 digits while I'm doing my math. When I'm giving my answer, I like to go ahead and stop at the second digit and round there, okay? But I'm just going to go ahead and go 3 places. This is just practicing here before we get to our math part. And again, I like to go quite a few places for my math. Over here, they're asking for the cosine of 53. Close parentheses, and hopefully you got an answer of similar to 0.602. And then the tan of 34 using the tangent button, 0.675. Give or take, we might be off by 100ths or 1,000ths by 1, but very similar, I'm sure, our answers. Now we're going to go ahead and use, it tells us right here, we're going to use SOHCAHTOA to go ahead and figure out our unknown. They gave us a leg, one leg, and they also gave us a theta. First step before I do anything is I go and find the right angle, draw an arrow to the opposite side. That is my hypotenuse. I label my adjacent because I found my theta and right angle and my opposite. I ask myself, what do I have and what am I given? I have this leg and this is what I'm looking for. Okay. Again, I know y'all all have some type of highlighter, so I'm expecting y'all to highlight it. Let's go ahead and use our SOHCAHTOA. We have the H and the O, the sine of the opposite over the hypotenuse. So sine of the theta equals the opposite over the hypotenuse. Let's go ahead and plug that in. The sine, do we have the theta? Yes, we do, 35 degrees. Equals the opposite, I do not have the opposite, that's my unknown, over the hypotenuse, which is 16. Again, we can either use the triangle method or we can do our algebra. I'll go ahead and do the algebra here. I'm going to multiply this side by 16 to cancel out. Multiply this side by 16. The next step is, for me personally, I'm going to go ahead and clear, and I'm going to hit the sign of 35 degrees, close parentheses, and I'm going to get that number because that's going to go here, which is 0.5735, and I'm going to round to 8. And I'm going to multiply that by 16. So the O leg equals 9.18. What is my SI units? Here it is, centimeters. There it is. Okay, there goes my answer. There goes my steps. Again, I'm just going to video it just for those who may want to watch it. I'm also going to take a picture and post that as well of the answers. Again, first step, I find my right triangle, draw an arrow to the opposite side. That's my hypotenuse. I find my theta as well as my right angle, and that's my adjacent leg, and then left over is my opposite. I'm going to highlight what I have and what I'm looking for. I have this leg, and I'm looking for this leg. So it looks like I have the H and the O again, which is the sine of the theta equals O over H. Not a problem. Let's go ahead and fill this in. The sine, our theta is 60 degrees, equals O. I don't have over H, which is 8. We're going to do the same steps as the question above. We're going to multiply this side by 8 to cancel. Multiply this side by 8. I'm going to come over here and clear it out and say the sine of 60 degrees. This number is really 0.866025 times 8 equals my O leg, or my opposite leg. I got 6.93. Let's look at our units. It says it right here, kilometers. Kilometers. Again, this also is another step that we're doing before we get to our big kid physics problems. Okay, and it looks like we got a problem over here for us to do. I hope you tried it and attempted. I understand that you're probably frustrated with this a little bit at first. It's going to take time. I promise you're going to get better. First thing, we just have to get those negative attitudes and thoughts out of the way. No matter how difficult this is, I understand the frustration. I do. But you have to practice to get better. Okay, so let's practice with this one. It says here, from a horizontal distance of 80 meters, the angle of elevation to the top of a flagpole is 18 degrees. Okay, let's go back. From the horizontal distance of 80 meters. All right, horizontal, that hopefully we all agree that's a horizontal line. And this horizontal line, they told us, is 80 meters. The angle of elevation, remember I told you in physics when we talk about angles, that's degrees. The angle of elevation to the top of a flagpole is 18 degrees. And this is some kind of flagpole right here. All right, I did my drawing. Calculate the height of the flagpole. Okay, so this leg is my unknown. Calculate that height to the nearest tenth of a meter. All right, we can definitely do that. Step 1. You find your right angle, draw that arrow, and this is my hypotenuse. Theta and right angle is going to be my adjacent, and my other leg is my opposite. Always label your triangle. Now, how do I know that that's my theta? Well, my person was standing over here, and with their eyes, when they looked up this way, they saw the flagpole stand up, and they were 80 meters away from it, and they were looking up at the flagpole. Okay, then because of this, do you see this right here, that line? That is my vector line. Okay, remember the tail end of the vector is going to be your theta. That's why this is my theta. Okay. But Miss Munson, I flipped it and drew it the other way. It's the same thing. It's just a mirror image of it. So if you drew your triangle this way or if you drew it this way, it's going to be the same. Okay, so let's go ahead and do our next step. We're going to label what we have and what we're looking for. And it looks like we have the adjacent leg, and it looks like we're looking for the opposite leg. Okay. There we go. All right, we need to highlight what we're looking for and what we have. So what we're going to do is, I see there's a right angle triangle, and when we see that, our first thing is our minds are probably going to go to Pythagorean theorem, which would be the easiest way. But when we don't have two legs, we can't use that. We have to go SOHCAHTOA route. So I'm going to go ahead and fill in my SOHCAHTOA. So, just so that we all have it. Ka, Toa. All right, I have the A and the O. Is that the sine? No. A and the O. Is that the ka, the cosine? No. The A and the O is going to be the tangent. Okay, so in this case, I'm going to use the equation of the tan of the theta equals O divided by A. Now let's go ahead and fill in our blanks with what we do have. The tan, do we have the theta? Yes, we do, 18 degrees. Do we have the O? No, that's what I'm looking for. And the A is 80. Okay, so let's go ahead and I would go ahead and use my regular basic algebra, or again, you are more than welcome to use the triangle. Multiply this side by 80 meters, cancel. Multiply this side by 80. I'm going to come over here, turn this on, clear it out. I'm looking for the tan of 18 degrees. This number now becomes 0.32492. Multiply that by 80. My O is 25 to the nearest, or did it say 10th? I got 25. Why did I write 24? I don't know. And I think it's a 10th, but normally I go to the hundredths, so I'm sorry. If you rounded it up to 26, I understand. I'm going to leave it at 25.99. Okay, meters. There's my answer. And those were my steps to do it. Okay. I know some of us probably had questions on that, and I understand. So here are the steps. Let's turn the page so that way we can see here. Well, let's look at this page. So I know some of us have questions on this as well. The first thing is they're trying to find out, is it time, is it a velocity, distance, or acceleration? So let's look at this. 2 seconds is a time. 3 meters per second is a velocity. I understand if you want to write speed, you're more than welcome to. I understand that velocity has direction, but don't forget that the equation for speed and velocity are the same because they're used interchangeable. 6 meters to the right, that's going to be some kind of displacement. How far is going to be some kind of displacement / distance. We use that D for both of them. 4 meters per second square is acceleration. How fast is going to be a velocity / I understand again, speed. How long did it take? T. How high? Distance / displacement. Okay, I'm going to keep going. I'm going to come over here. A person swims to the other end of a 20-meter long swimming pool and back. What is their displacement? Remember what I said. I think the best bet to do, or the best thing to do in physics, to go ahead and always draw it out. So here's the swimming pool, and they swim 20 meters long pool and back. So they swim to here, which is 20 meters. They turn around, they came back. So they started here, and they ended here. And my correct answer is 0 meters. Why? Because my initial equals my final. They're the same number, 0. Does it mean that that person traveled 0? No. The displacement is 0. A rock falls, what does that say? 15 meters. It is vertical or horizontal motion. So if a rock falls 15 meters, is this a vertical or horizontal? Vertical. What is the displacement of that rock? Negative 15 meters. That is the correct answer. Some of us did not get that negative. I understand. But when they use the word displacement, if you put 15 meters falling down, that works. If you put 15 meters downward or down, that also works. But to shortcut it, negative 15 meters would be the right answer. Let's keep going. Number 4, a car moving 12 meters per second stops in 3 seconds. What is the final velocity? Well, if it stops, 0 meters per second. Okay, they're just using the kinematic information, and don't forget, words in physics have number value, number 1. Number 2, they try to trick you all the time. You really have to read what they're talking about and see if they're trying to trick you. Next one, number 5. Number 5 says, you throw a rock into the air and catch it as it returns. What is the displacement of this rock? If you catch that rock where you tossed it up at, the displacement is 0 meters. Okay, 0 meters. I'm going to come over here to this side. And this side says here, choose the correct kinematic equation for the following. Okay, what is missing from this list? Well, what is missing is the t. I think somebody may have asked me. I'm not sure. I might have misquoted. This is my unknown. Hopefully we can all tell there. What is missing is my t. So the equation I'm going to use, using my flow chart from my note from last unit, again, having your notes and everything printed out, having them organized in a binder is going to be the best helpful thing you can do to yourself. Okay, do it for yourself. Help yourself out. Was displacement or distance ever used? Yes, it's my unknown. Was t ever used? No, it was missing. So what equation am I going to use? The flow chart is going to route you to the acceleration equals vf squared minus vi squared over 2 times the distance. Now, again, remember what I told you. Don't trust the flow chart because it's just there as a guide. Let's check it out. Could we use this? Do I have acceleration? Check. Do I have the VF? Check. Do I have the VI? Check. Do I have the 2? Check. The distance is my question mark. Since that's only one question mark and no X's, yes, I can absolutely use this equation. Okay, hopefully we're getting better at this now, right? Let's go ahead and keep going. What is missing from the list? I'm going to just draw a little line here. So that way I can separate this problem and that problem. There. Well, if this is my unknown, VI, it looks like is missing from the list. What equation am I going to use? Let's go through our flow chart information. Do I have the D? Yes. I'm looking for it. So yes, it's part of the equation. Do I have the T? Yes. So in this case, I'm going to go ahead and go with the D equals VI times T plus 1/2 AT squared. Remember what I told you. We kind of got to go back and double check it. Do I have the D? Question mark, because that's what I'm looking for. The VI? No, X. The T? Check. 1/2? Check. The A? Check. The T? Check. Could I use this equation? No, I cannot. I cannot. This is that one time that the flow chart, I can't use it. But remember, there's a little trick that we memorize because it's not in our formula chart. We cannot use this equation. D equals VF multiplied by T subtract 1/2 AT squared. That is the correct equation. Okay? That is our correct equation. What is missing from this list? Alrighty, I'm going to draw another line just so I know the separation. There we go. I am missing, looks like we're missing the D. T is my unknown. So what are we going to use? Let's go ahead and go with our flow chart. Is D ever involved? No, it's not. Then my flow chart tells me to stop and use this equation. V sub F minus VI over T. What do? I double check it. Do I have the A? Yes. Do I have the VF? Yes. Do I have the VI? Yes. Do I have the T? Unknown. I'm only one question mark. So if I have one question mark and no x's, I absolutely can use this equation. So that's going to be a good equation. Okay, so this was practice before we actually do our kinematics. So let's go ahead and practice our kinematics, make sure that we're all on the same page. Number 7, in 10 seconds, t, a car accelerates 4 meters per second square, a, to 60 meters per second, v sub f. How fast was the car going before it accelerated? How fast was it going before? The key word is before. V sub I is my question mark. Okay, so this here and here, this is just to help guide you. That's what this is. So the t is 10 seconds. The a is 4 meters per second square. The VF is 60 meters per second. The VI is my unknown, and D was never discussed or used. Using my flow chart, was D ever used or discussed? No. So it tells me then I can go ahead and I can use A equals VF minus V sub I over T. Before I do anything, I go back and double check it. Do I have the A? Yes. The VF? Yes. The VI? Question mark. The T? Yes. Can I use this equation? Yes, I can. Let's fill it in. 4 equals, and again, you can more than welcome to put this into the triangle. T will equal, let's do that. I'm going to put it algebraically, put it into the triangle. T equals VF, which is, I'm not looking for T. Why am I messing myself up on this triangle like that? I circled the wrong thing. I'm looking for this. So V sub F minus V sub I equals A, which is 4, times T, which is 10. The VI I'm looking for, the VF they gave me, which is 60. Take away the VI. There we go. Now let's go ahead and let's work out our steps here. This is going to become 40. If I subtract that VI, I need to get the 60 by itself. So to do that, I'm going to have to get rid of the 60 so I can get the VI by itself. This 60 here I see is a positive value, so I'm going to go ahead and subtract 60, cancel, subtract 60. I have a negative VI, which equals, we've got a positive 40, subtract 60. So what did you get on that one? Hopefully you've got a negative 20. Right? But that's not going to cut it, and that's not going to be okay, because I need to get this negative away from my unknown variable. So to do that, I'm going to divide by negative 1 to cancel. Divide by negative 1, cancel. The VI equals 20 meters per second. And that's my answer. Okay. Again, it's just the kinematics from the last unit that we went over and we did. We're just carrying it on again. Number 8. Let's practice number 8. The object is moving 2 meters per second, experiences an acceleration of 3 meters per second for 8 seconds. How far is what I'm looking for. So this is what it was going first, the V sub I. Then it accelerates, so it must have got faster. But we want to know question mark distance. Let me come over here and fill in my blanks. The T was 8, the A was 3, the VF, I don't know. They never gave it to me. The VI, though, is 2, and the D is question mark. Go through your flow chart. Do you have your D? Yes, it's part of my unknown, so it's part of my equation. Do you have your T? Yes. So it tells me to go ahead and use D equals VI times T plus 1/2 AT squared. Remember what I said? We can't trust it. Let's go ahead and always double check it. Do I have the D? Question mark. VI yes. The t, yes. 1/2, yes. A, yes. The t, yes. This is perfect. Not only that, but it's already set up algebraically the way I need it. So all I'm going to do is plug in everything, multiply everything, and add, and I should be good to go. So D equals VI is 2 times 8 plus 0.5 times 3 times 8, square the 8. 8 times 8, what do we got? 64. Okay. Times 3 times 0.5. What do we got? 8 times 2 is 16. So D equals 16 plus, we've got multiply 64 times 0.5, which is really dividing it by 2. So that's going to be 30. I'm trying to do it in my head. 32. But yeah, I still need to multiply that by 3. So I'll put that in parentheses. Plus 16. Your distance looks like it's 112 meters. That's what I got. I hope you got the same thing. If not, here are the steps to help you out. Why are we doing this, miss? We're doing this because the last section of our notes is going to be parabolas. And to solve for parabolas, we need to be able to do our kinematics. So we're just kind of going back and pulling that information back again, so that way we're ready for those parabolas. Let's go to number 9. An object at rest starts accelerating. Whoa, at rest. VI is 0. If it travels a distance of, that's my D number, 40 meters, to end up means V sub F. Well, what is the acceleration? Let's fill in everything over here. Was T ever given to you? Over here, no, it was not. A is my question mark. VF is 20, VI is 0, and D is 40. Let's go ahead and use our flow chart. Was D ever used or discussed? Yes. Was T ever used or discussed? No, it was not. So I stop there. My flow chart tells me A equals VF squared minus VI squared over 2 times D. Remember, we don't trust it. We go back and double check it. Do I have the A? Question mark. Do I have the VF? Check. Do I have the VI? Check. Do I have the 2? Check. Do I have the D? Check. Can I use this equation? Yes, I can. Not only can I use this equation, but I don't even have to algebraically rearrange it. I can leave it as is, get the top numbers done, get the bottom numbers done, divide those numbers, and I can find my acceleration. So let's go ahead and do that. A equals VF of 20 squared minus 0 squared over 2 times 40. Okay, 2 times 40 is 80. If I subtract 0 squared, which is 0, then I'm subtracting nothing, right? 20 times 20, right? Hopefully we all agree that that's going to be, or what is it? I wanted to say 40. I know it's not 40, it's 400, right? 20 times 20, because I don't want to mess up. That's 400. I almost said 40. 400 divided by 80. I got, hopefully you got the same thing. A equals 5 meters per second square. Okay? That's what I got. All right, absolutely, we can do these equations. I promise you. Follow the flow chart. Do my steps that I do in the video, which I label my questions. I write down all my variables. I go use my flow chart while I'm coming up with the equation. I double check to see if that's the right equation. If it is, then I go ahead and I solve for it. If not, then I've got to go and investigate which equation is going to work with the numbers that I was given. Okay, let's keep going. Number 10. A model rocket climbs 200 meters distance in 4 seconds t. If it was moving 10 meters per second to begin with, v sub I, well, what is the final velocity? What question mark v sub f? Let's fill in the blanks. V sub f is a question. VI is 10. Distance is 200. T is 4 seconds. A was never given. Put an X there. Use your flow chart. Was D ever involved in the equation? Yes, it was. Was T ever involved? Yes, it was. So my flow chart actually tells me go ahead and use this equation. D equals VI times T plus 1/2 AT squared. What did I say? We don't just trust it and take it. We're going to go ahead and first double check it. D, do I have it? Check. VI, yes, it's 10. T, yes, I have it. 1/2, yes. A, no, I don't. And T is a check. Well, let's look. It looks like I don't have the A, okay? And I have everything else. So for some reason, it wants me to go here first and solve for the A. But I really want to solve for the V sub F. Can I go back and use the regular acceleration equation? No, I can't. Because on the other acceleration equations, you have to have the A or VF. I can't be missing two variables like that. So my flow chart was awesome. It sended me here and guided me to this equation first, solve for A, then I can plug A in to solve for the V sub F. Okay, so let's go ahead and do what it told us. D is 200 equals 10 times 4 plus 0.5 times A times 4 square. 4 times 4 is 8. 10 times 4 is 40. 8 times 0.5 is, 8 times 0.5 is 4. So 200 equals 40 plus 4A. Okay, not a problem. We can solve this. Let me come back over here. I'm going to get rid of this 40 by subtracting 40 on this side, subtracting 40. That equals 160 equals 4A. Divide by 4, cancel, divide by 4. Let's see, 160 divided by 4, I've got 40. Now that's not my answer. I'm going to come over here and I'm going to put 40 here. But that's only step 1. And I'm going to put a little 1 over here. Draw a little line and put this as number 2. And now, since I have 4 out of the 5 variables, I can choose and pick whichever equation I want to use. Well, I'm going to use the easier of the 2 accelerations. I'm going to use A equals VF minus VI over T. Okay? It's algebraically already arranged for me. So, actually, no, I need to look for the VF. Let's come over here and do the triangle